Oh, hey there, and thanks for tuning in to the Daily Space Weather. When we've stated repeatedly that we've got the ultimate solar imagery and most comprehensive space weather in the known universe, were you listening? Anyway, congratulations on realizing the channel exists. Here's some imagery of the closest star. You might see this make the runs around the internet today. Hopefully it won't give you the runs, as it's not going to have very much of an effect on you. It is a massive filamentary coronal mass ejection coming out of the north solar polar crown filament. We've been showing it for days on the channel. Here it is in some other wavelengths. That was 193 plus 304 angstroms. This is 211 plus 171 angstroms. So let's go back to that. That's ionized helium plus iron. And here are two separate species of ionized iron. Yeah, there was a massive coronal mass ejection associated with that, and you can see some secondary flaring as well as plasma splashes back down toward the chromosphere. Here's the first indication. You'll see that plasma indeed ejecting at quite a high speed. Not a super high speed ejection, but you can see the way it accelerates as it diffuses out of the sun's atmosphere, known as the corona. There's an even further zoomed out view for you. We've slowed this down to 15 frames per second to allow a little bit more detail there and a little bit more time to process all of that. Here's an even further zoomed out view as that plasma is now on its way blasting out through the solar system. That started at about 2200 Universal Time yesterday on June 11th and continued into this morning. So this is the reason why we show filaments on the channel, because they have a tendency to do that. And let's get back to here are some 24-hour videos. Lots of plasma instability happening on the western limb. You're going to see a lot of stuff moving around over here. Also, a new active region rising over here did produce a flare as we produced the show once again today. If you've got comments to leave directly for the sun, just leave them in the comments section. Many of our viewers are convinced that the sun watches our videos. Let us know in the comments if you think stars are conscious. So here's another close-up of that insane crown prominentiary filament that we've been showing for days, with the likelihood that things like this will happen. So there you go. You could call that a forecast. And that is some interesting imagery. I would also note how you can see plasma splashing back down. Downflow effects also cause minor solar flaring. You'll see some brightening there as that plasma heads back down toward the chromosphere. Here's the equatorial view in ionized helium, 304 angstroms. And we'll be monitoring filaments throughout the day today, as we do regularly on the channel. Filaments, filaments, filaments are the story indeed. There you can see some rather large ones setting in the southwestern limb. A huge one south of that sunspot there. All over the solar disk you'll find filaments. There's one right under the Earth scale. You can see that one doing some reorientation there. Some chaotic flows happening indeed. And let's don't forget the northeastern limb, as there is a new sunspot likely rising just behind these loops right over here above our Earth scale, right about there. A new sunspot likely rising as it has been producing some flaring right now. We'll get to it and show you some closer to real-time data. Those are 24-hour videos from the SDO, the Solar Dynamics Observatory. Let's take a look at sunspots here, which have degraded a bit over the past 24 hours. We've seen a little bit of a downtick in solar activity. in terms of the radio flux and the sunspot number, and an uptick in filamentary activity. Certainly. Here's your colorized magnetogram. These SDO browse data images feature yesterday plus today. So that's all the data from June 11th and so far today's data on June 12th. Let's take a brief moment to see what's going on planet Earth, as there are some volcanic eruptions going on, like Shivaluch, now back on the list, as Shivaluch now exploding, producing a 12,000-foot plume of volcanic ash. Please do not pole vault the caldera. No matter how much disinformation you get from certain organizations, Tsuonose Jima is also erupting. It's producing a 6,000-foot ash plume, flight level 060. And the Japanese Meteorological Agency has lowered the volcanic alert level from 3 to 2. In terms of the restriction, you can now get to 1 kilometer instead of 2 kilometers from the caldera, I guess. And what has happened? I have turned weird colors. What is going on with that? I've turned strange colors. Okay. Pretty sure I carefully set this before streaming this video. Check it out. I'm in there we go. I'm in oddly, I don't know what was up with that. I'm glad I checked. Looked like something out of a horror film. Mount Mayon is continuing to erupt as well. We've got some lava flows there at the Philippines. So Mount Mayon, not just dropping incandescent lava bombs down the hill, also some lava flows happening there. So some new real estate happening in the Philippines. Tocono also erupting, 7,000-foot ash plume as Tocono explodes. Kilauea producing some 9-meter lava fountains there and some new lava flows. And the spatter cone is growing as well. So for all you real estate investors in Hawaii, the Big Island is getting bigger. Popocatépetl exploding as well in central Mexico, flight level 230. That's a 23,000-foot ash plume, 14,000-foot ash plume from Fuego in Guatemala, 19,000-foot ash plume from Sangay in Ecuador. It's a flight level 190. Not sure about Revenador. Don't assume it's not erupting and decide to pole vault the caldera. And Sabancaya is exploding in Peru. That is a flight level 240, a 24,000-foot ash plume. And as far as what's going on seismically speaking, allow me to get off screen with my odd. Maybe I'll stay off screen. Anyway, there's seismicity for the past 90 days. And here is the 24 hours of 5+ magnitude earthquake report. There was a 5.2 at Papua New Guinea. That was at 11:34 Universal Time yesterday morning. There was also a 5.8 near Macquarie Island. That's one of the largest quakes of the past 24. That was at 13:08 Universal Time. A 5.0 struck central Alaska there. Pretty far north for a quake at Alaska. The Volcano Islands there, south of Japan, had a 5.0. That was at 1:23 Universal Time yesterday. And the Solomon Islands had a 5.0. That was at 6:11 this morning, and that is where the earthquake list ends. Let's get back to space weather data. And I don't know what is going on. Maybe there's radiation from space showing up and it's messing up my color keying. I don't know. Maybe I'll just turn it off entirely. All right, I'm going to try to fix it on the fly, folks. I don't know what's going on with it. I carefully set this most days so that I'm able to appear on screen. As long as my face doesn't look distorted, I'm cool with it. So let's just move on. Here's the past 24 hours in SDO 211 plus 171 angstroms. And the 10.7 centimeter radial flux has dipped to 154 solar flux units. There is the 1-year graph of the radial flux depicted by that upper black line. So it looks like there may be a breakout happening here despite a small downtick in solar activity for the past few days. Space Weather Enthusiast dashboard. This is NOAA's forecast, not containing any geomagnetic storm or geomagnetic unrest conditions. We are expecting a coronal hole high-speed stream here in a few days. We'll get to that forecast in a moment. First, some additional space weather data. These are the past 4 hours of Earth's likely magnetic moment from space. This model is created by what's called the Space Weather Modeling Framework, and if you want to download the software for that, you can. Just click the Details tab on the Geospace Magnetosphere movie. You'll have a link to the Space Weather Modeling Framework. There are a lot of variables to create that 4-hour Geospace Magnetosphere movie. That's what's going on, Earth's magnetodynamic pressure from space. Next, our magnetic moment from the ground. This is magnetic flux density on the ground level. The units are nanotesla. Again, it's also a product of the Space Weather Modeling Framework, just for the ground level as opposed to for space. And again, we do have geomagnetically calm conditions at the moment. KP index is only at 1.33. The planetary K index is a global geomagnetic average. Real-time solar wind here, pretty unremarkable as well. We've got a weak coronal hole high-speed stream. It's not that high of a speed, and even the density didn't really get that high. Current conditions are about 4.3 protons per cubic centimeter for the solar wind density. Solar wind speed about 438 kilometers per second. Next, our GOES magnetometers. Not seeing a lot of sawtooth readings there, as this coronal hole high-speed stream is weak, very weak. And if we didn't have such low solar winds going into it, there would barely be a signal to detect. Next, we'll look at the heliospheric current sheet. Yeah, the heliospheric current sheet. And Earth is currently in a South Pole-oriented current sheet, having snapped in there yesterday. North Pole current sheet rotating away there in the west. The beefy part of the South Pole current sheet here rotating in from the east. That depicts the last 4 days. So here's the line of sight field plot. There you can see the sun's B field depicted in blue, north solar polar field in green, south solar polar field in red, and the gong magnetogram in grayscale there. Seems like an appropriate time to move to coronal holes. So there's our line of sight coronal hole plot. And we've got South Pole-oriented coronal holes here dominating the eastern portion of the solar disk. Let's take a look at those by subtracting the 171 angstroms wavelength from this 24-hour video. There's just 211 angstroms by itself. So your sector boundary crossing is right about here. Let me try that again. It's right about here. These are North Pole. These are South Pole coronal holes. And these type of coronal holes over here, the ones that span the equator, are the most likely to produce things like geomagnetic storms and geomagnetic unrest conditions on the planet. They are the most geo-effective type of coronal holes. Coronal holes are like low-pressure systems on the sun, folks. They are the source of high-speed solar wind. So there are protons blasting out of these coronal holes, creating what we call the Parker spiral, a fairly consistent and reliable little radio jet feature there. Again, there is a flow of protons coming out of there. Coronal holes are the source of high-speed solar winds. And let's move to sunspots. Yeah, sunspots. Some people are obsessed, and they are just a feature of the solar cycle. There are a lot of other features, especially considering the actual mechanisms that likely underlie the solar sunspot cycles. So here's a sunspot situation. I don't know what they have against naming sunspot 3333. It hasn't been named. Maybe it's evaporated. I don't know. We'll take a look here in a moment. It's been there for days. Maybe somebody's trying to make the sunspot number lower to make their predictions come true or something like that. I don't know. It's a little disturbing because that sunspot it's clearly been there for at least 2.5 days. So I don't know why it's not named. It's just not named because reasons. So here is the past 24 hours, and again, you can clearly see that sunspot there. We've documented it for days. It should be known as sunspot 3333, and it's actually grown since yesterday. So, I mean, you might be able to call that a new sunspot growing in front of it there, but it looks like two groups there. I would say that's 3333, this one here, which has been there for days, and 3334, which is now formed ahead of it. So a little bit of sunspot growth happening there. Also a new sunspot rising up here in the northeast. I don't know what's up with it. I am not paid to name sunspots. So it's whatever. Whatever. Let's get to energetic particles and solar flares. There's the GOES proton flux for the past 3 days. And no spikes in the proton flux there. And again, a little bit of flaring activity happening as we produce the show. By the way, that crown prominence eruption wasn't really associated with any flares. It started around 2200 Universal Time. So anyway, that's what's going on in terms of solar flares. Remember, folks, don't get solar flares and coronal mass ejections confused. Solar flares are photons, X-ray photons. Coronal mass ejections are primarily protons, namely hydrogen nuclei. So here's one of our flare wavelengths. This is 131 angstroms, part of the extreme ultraviolet spectrum, one of the many species of ionized iron covered by SDO. And yeah, that's the past 24 hours. Again, keep your eye on the northeastern limb as there is a new sunspot rising up there. So here's 94 angstroms, the other wavelength that takes 10 images per minute. Five times as many images per minute as the other wavelengths. 94 and 131 angstroms. They are specifically designed to view solar flares. Looks like an active region rising down here in the southeast as well. So we can expect 2 new named sunspot groups whenever anybody decides to actually name the sunspots as they're supposed to be named when they've been on the solar disk for more than 12 hours. And so we're expecting 4 new sunspot groups. That's the sunspot forecast. Expect 4. Man, oh man. Expect 4 sunspot groups. I guess I'm all full of dark energy today. I don't know what's up with it. I'm full of dark energy, folks. Now, if you want to read more about solar flares, there is a great article on Wikipedia about it. We talked earlier about how plasma crashing back down toward the chromosphere, which is sort of the middle layer of the sun's atmosphere, does cause secondary flaring. And, you know, there are various different types of solar flares. There is an article on Wiki about it. So have a look on that. Basically, what we saw there is it's like a post-eruption arcade flare, a supra-arcade downflow, really is what was kind of going on there. And, of course, we've covered it regularly on the channel. And, of course, there is conjecture about what causes flares. I won't get into it on this video. That's for some other astrophysics or heliophysics or even cosmology content. By the way, if you enjoy the content, don't forget to press like, subscribe, share, etc. And if you'd like some additional content, become a gold or silver Smash Team member at smashomash.com/SmashTeam. We realized that we needed to forge our own path as we needed the additional capabilities that we are afforded via our own website, smashomash.com/SmashTeam. Thanks to our gold and silver Smash Team members. These videos are brought to you not only at massive personal risk and expense by Smash staff and I, but also by our viewers. So thanks again to the gold and silver Smash Team level members. There is also a bronze membership, which will cost you $0 per month. You can also follow us on Instagram if you want to see more fitness, lifestyle, and some posts there that are unrelated to space weather. You can find us all over the internet at Smashomash. And getting back to space, this is what's going on overhead Lehigh Valley, Pennsylvania. Just click the Now button on your own star chart after you put in your location at skyandtelescope.org. It's the one we use. I like the way you can move this little box around and show what your view will look like. Saturn and the moon are up there, and it is cloudy. It's about to start raining in the mid-Atlantic states. Yeah. We'll get to a weather forecast here after we cover more space weather. So I guess a solar system forecast counts. Here's your solar system forecast. We're going to show you where things are today. Ta-da! And there's where things will be in a week, on the 19th, coming off of the new moon, where we'll have a bunch of well-rested reverse werewolves. Next, coronagraphs. And we covered a sun-diving comet, which looks like it broke up as it got closer and closer to the sun. You can see that in those 105 frames there. Right there, that comet coming into view. We covered it yesterday also. That is 105 frames from yesterday, June 11th. This data courtesy of George Mason University. And here are today's frames, which will be a little more exciting as you see that massive coronal mass ejection there coming out of the north heliographic polar region. A great example of a highly filamentary coronal mass ejection. Now, we've described many different types of CMEs in the past. Let's take a look at some more imagery. There is Soho-Lasco C2 and C3. You can see that comet, which was already breaking up as we covered on yesterday's daily space weather video, by the time it appeared on the coronagraph, as there was a large fragment ahead of the nucleus of that comet. That was pretty interesting. We'll also show the view from stereo A, along with Soho-Lasco C3. And we show this diagram because stereo A is so close to the Earth. As stereo B and the Earth overtake each other, stereo A overtakes the Earth. Anyway, there's a great view from another coronagraph, stereo A, along with the Soho-Lasco C3. And don't worry, we've also got some custom images. So here is 193 angstroms by itself. And again, you can see a lot of plasma out here suspended by the massive magnetic fields of these new rising sunspots. So there's a high potential for coronal mass ejections all over the solar disk. Let's take a look at some. These are 24-hour videos. So here's the zoomed out view. Not every day that you see a sweet image of a comet and a massive coronal mass ejection there happening around the same time. And if your question is, do I think the comet caused the coronal mass ejection? The answer is no, as that will definitely make the rounds today as well. So here's a little closer view of that. These are 24-hour videos. That is pretty sweet. Oh my God, the comet must have caused the coronal mass ejection. People think that the planets are in charge of solar activity and all this other insane stuff because, I don't know, they think everything's connected and that the universe is electric, which is a truly idiotic notion, as if it's some kind of new information. Hey, did you ever consider the possibility that the universe is electric? Yeah, I considered it, and I've determined that it is idiotic. Okay, so there's I think that's our last 24-hour video for you there, folks. Let's briefly just cut back to this, where we started today's video out. That is, how you like them apples? Like I said before, let us know in the comments if you think our channel provides the most comprehensive space weather and detailed solar imagery you'll find in the world. We hope you've noticed that this is 100% the case. I am not interested in anything that isn't the truth. The truth is out there, and we are bringing it to you on the regs. So like I said earlier in the video, filaments are the story. I mean, we've got like over a dozen filaments here on the Earth-facing portion of the solar disk. You see all those dark areas that are overlapping the solar disk? Those are called solar filaments. You see those bright areas that are hanging off the edge? Those are called prominences, which are also solar filaments. And we've got a lot. I mean, let's call this 1. We'll call this 2. This will be 3. Here is 4. Here's 5. So at least 5 major ones. And some of those may consist of multiple different pieces that are not technically the same filament. That's the ground-based hydrogen alpha telescope at El Teide, Spain. And yeah, the likelihood of coronal mass ejections remains at 100%. So here are the past couple hours, and like I said, there is a flaring region rising right over here. There's that recent C-class flare there rising over the northeastern limb. Also a likely sunspot rising in the southeastern limb. So we should have 2 new named sunspot groups today, 3333 and 3334. If it doesn't happen, it should happen, and it should raise the sunspot number because, hey, look, sunspots. Hi, sunspots. Let's move to our bonus feature segment. Starting with satellite charging hazards, which are not there. It's clear sailing for satellites. Electron flux here kind of low. Again, we are experiencing a coronal hole high-speed stream. It is very weak, so we're not expecting the electron flux to be super low. There is the 1-year graph. It is quite low, despite the weakness of that coronal hole high-speed stream. And there is the forecast model. NOAA was right on the forecast here, expecting a little uptick in the coming by tomorrow, and I would tend to agree. We'll have to see what happens. The electron flux is measured at the F layer of the ionosphere, so let's take a look at the vibrational frequency up there at about 300 kilometers of altitude. The ionosphere animation that we show daily is one slice of the atmosphere, the bridge between Earth and space. Here is the vibrational frequency of that layer. This does give us insight into what's happening with the puffing up of the ionosphere during things like geomagnetic storm conditions, which we ain't got. We ain't got geomagnetic storm conditions. We've got calm conditions. So the ionosphere is looking pretty normal. Here's the anomaly gram, which is anomaly in megahertz from the 30-day median. And there is nothing to write home about there going on in the ionosphere. If anybody is telling you that the world is ending because of space, there would be a signal in the ionosphere, but there's not. There's 10:45 universal time. Things looking pretty normal. The total electron content is the free electrons, all the way from about 12,500 miles of altitude down to your ground-based handset. And we do have some huge GPS errors happening here south of the equator. Yeah, huge high electron content anomalies here, mainly in the southern hemisphere. Also some in the north, which we will get to for North America at least. That is your coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Those free electrons cause signal refraction from the ground level through the ionosphere, the inner plasmasphere, the inner Van Allen belt, the outer plasmasphere, and even portions of the outer Van Allen belt. Here is the North American anomaly from the 10-day average. And things are looking pretty normal over North America there. No major high electron content anomalies, and only some minor low electron content anomalies. We'll close out space weather before moving to Earth weather with the latest colorized magnetogram and intensitygram. So here are these new sunspots that, I mean, this one here has been there for days. That should be 3333. This one here should be 3334. There may be even another one out here. 3335 will be the name of that one. Again, we've got 2 new rising active regions in both the northeast and the southeast. They are not showing up yet on the colorized magnetogram or the intensitygram. Regarding the rest of those sunspots, they've largely degraded. The most likely place to see a large coronal mass ejection at the moment is, in my opinion, over here, as we see lots of plasma instability happening there. And let's move to Earth weather. So there's a huge low pressure system out here in the North Atlantic. If anybody on YouTube is telling you that low pressure systems are just like sunspots, they are imbeciles. Utter imbeciles, as low pressure systems on Earth are more like coronal holes on the sun than they are like sunspots. They're really nothing like sunspots, as sunspots are a location of massive high magnetic pressure on the sun, which is more like an anticyclone, which is more like this over here. A high pressure zone, which, did you know that high pressure zones blow? Yeah, high pressure zones blow, and low pressure zones suck. Low pressure zones rotate counterclockwise in the northern hemisphere and pull air in. High pressure zones rotate clockwise in the northern hemisphere and push air out. A huge difference. Low pressure zones, like hurricanes, for example, are absolutely nothing like sunspots. They're indeed the opposite of sunspots in terms of atmospheric pressure, because a coronal hole on the sun is a low pressure zone and a sunspot is a high pressure zone. So I know there may be some idiots on YouTube that are telling you that sunspots are just like hurricanes. That is because they are morons who do not understand heliophysics or atmospheric physics, probably. Maybe one or the other, but most likely they don't understand either, or they wouldn't make such an idiotic and mentally handicapped, deluded claim. Anyway, let's take a look at the highest and lowest pressures on the planet. Antarctica is featuring some pretty high pressure indeed, the highest, driest continent. 1,069 hectopascals. And that's perhaps the lowest pressure in the world, 954 hectopascals. That is indeed the lowest pressure in the world. Oh, now wait a minute, I forgot about this one. Yep, the Southern Ocean features lower pressure than that cyclone, which is licking the shores of India. Anyway, let's get back to our regularly scheduled meteorological information. Here are the surface winds of the eastern world. Again, you can see 2 typhoons there, one just south of Japan and one about to make landfall there west of India. These are the jet streams of this side of the planet. And by the way, if you want to do your own hurricane forecasts, try using the sea surface temperature map. If you click on ocean and sea surface temperature, it'll help you with that, and you can see lots of hot water there for both of those systems, especially the one in the Indian Ocean. I mean, that water is like nearly 90 degrees there. That is indeed on the warm side. So those are the jet streams. Here are the jet streams of the central world. Here are the surface winds of the central world. And you can see that low, it's sucking air in. Also, low pressure systems are like a lifting up of the atmosphere. So right here, this is actually puffing the ocean up here. That is what part of a storm surge in a hurricane is. A low pressure, it's less pressure on the water, which allows the ocean to actually bulge up. It's part of what a storm surge is. Anyway, those are the surface winds of the west side of the world, and these are the jet streams. Next, we've got a lovely animated satellite map here from windy.com, and shout out to our viewers from all around the world. Just spectacular imagery there. And you can see the sun here as the sun rises over the eastern U.S. Here's a little closer view of clouds and fog. From the satellite perspective there, that's the shortwave radiation satellite, part of the NASA GOES interactive weather satellite suite, clouds and fog over the Americas. As some rain finally rolls into Pennsylvania. It's in extreme drought conditions. So here's your weather.gov map, and check it out. We've got frost advisories on the Upper Peninsula and northern Wisconsin, and excessive heat warnings in Texas and Oklahoma. So a huge variation of temperatures here across the U.S. Also, it looks like a child abduction emergency showing up there on the map. If your location is lit up on the map, click your location and find out what your warnings are. Here are some forecasts. This is the 72-hour GFS forecast, and it looks like some snow showing up there in the forecast for parts of Colorado. So all the hot air coming out of that state is insufficient to prevent additional snow here in the middle of June. And if you think it's going to be a year without a summer, go look at the Gulf Stream. It's not shutting down. Some strong storms coming to the Gulf states once again there in their 72-hour GFS forecast. Especially Alabama, Georgia, and Florida and South Carolina going to get hammered here in about 3 days. As a low loiters over the central Great Lakes. Next, your total accumulated precipitation forecast. Heavy rains there expected for both Alabama and Georgia, exceeding 4.5 inches there. Last but not least, the temperature anomaly forecast, since we've got exceedingly cold and exceedingly warm temperatures showing up. There you can see those very hot temperatures showing up in southern Texas and very cold temperatures showing up in large portions of the central U.S., including Colorado. That hot air, maybe the hot air is shutting down, folks. Is the hot air in Colorado shutting down? How could that be? These people are paid 6 and 7 figures to misrepresent science and just outright lie to their viewers. Anyway, that's your 72-hour GFS temperature anomaly forecast. Keep in mind it is in degrees Celsius, so when you see that purple, that's 16 degrees Celsius below average for this time of the year. Yowzers. Next, your lightning map. We've had some significant lightning here, especially in the southern portion of the U.S. That's the past about 10 hours, and let's take a look at a real-time lightning map to see if we've got any terrestrial strikes. Oklahoma's got quite a bit of lightning there. Let's see what's going on. Hey, Oklahoma City, you've got lightning to your south and your west. There's some active cells there in Pontotoc County? I don't know. Ada. There's thunder rolling in for sure. There's your real-time lightning map from lightningmaps.org. As lightning continues here north of the Mediterranean. It's been going on for, dare I say, weeks. And let's move on to our affiliate/sponsor. So these videos are also brought to you by our affiliate/sponsor links. So visit those if you want to support the channel. Perhaps pick up your Hemp Lucid products via our link. You can also use the promo code from hemplucid.com. Just enter the promo code SMASHOMASH. That'll save you 10% on checkout. Thanks to everybody who's picked up products. I used the mushroom gummy sleep product last night. I also took one of the CBDs, and I also used the mushroom focus gummy before yesterday's bike ride. So again, if you want to see the lifestyle posts and so on, hit us up on Instagram. Enter the promo code SMASHOMASH to save 10% on your Hemp Lucid orders. Great products there. They make great gifts. You can find links below this video as well on the homepage at smashomash.com. And welcome to the Neo Renaissance. The official homepage of smashomash.com is the official homepage of the Smash News Network, least busted name in news. Yes, it is a dig on CNN. Is smashomash.com. We launched it back in 2019 because of pathetic censorship on Facebook. And we've also got an Amazon shop, which you can link there. Right there is the link to our Amazon shop. It's amazon.com/shop/smashomash. And we just put up a video yesterday about.
Oh yeah,
check it out. Yeah, that's hot, right? It's Anthony's cocoa. Buy your items in bulk. Get your cocoa through our store and chocolatify your life. Yeah, chocolatify your life via our Amazon link. Today's featured product is part of the Smasho merch. You can find that linked on the homepage as well to the Smasho merch. It's Google defined, and I'm wearing the shirt. Now, we're interested in what search engine you use. These videos are designed for YouTube, a video sharing platform which is powered by the Google search engine. So if you are using Google as a verb, we implore you to please use it correctly. As if you're using Google as a verb, it should mean to obtain biased information using the Google search engine. If you want to obtain biased information on the World Wide Web, make sure that you go to google.com. Yeah, google.com, the world's leading source of biased information on the internet. Now, it makes my ears bleed when somebody uses Google as a verb, but hey, that's okay. Lots of people are utterly outdated and ossified in their confused beliefs. So, anyway, just figured I would share some facts about biased information on the internet. If you're using it as a verb, we just hope you're using it correctly. Press like, subscribe, share, etc. if you enjoy the content. It's only the world's most comprehensive daily space weather as well as best solar imagery in the known universe. Thanks to all of our new subs, new viewers, etc. Don't forget to press the share button. And if you've got people with attention spans of 15 to 60 seconds, share our shorts. youtube.com/smashomash/shorts. Eat my shorts. That quote brought to you by Bart Simpson. Anyway, this is the current situation for precipitation over our U.S. weather station. It's radar.weather.gov. We'll focus on the lower 48 and close this mother out. This is the space weather and earth weather together. There is your clouds and fog view, shortwave radiation from the satellite for the lower 48, and there is the water vapor map. You can see we've got some impulses from Canada here. So this is an important one. We've got this cold air pushing down once again, creating frost advisories in northern Wisconsin and the Upper Peninsula. And this dry mass of air is going to just slowly kind of provide an impulse there. Also keep in mind there is a low that's going to form right up here, and it's going to just kind of hang around. So the Great Lakes is where a lot of the action is going to be at. And as far as the moisture, it's down here in between Louisiana and Georgia. If your Doppler's not obvious, it may not be obvious what's happening there. Some strong storms here just about to move out into the ocean and into places like Arkansas. Anyway, this is your recap. Doppler, there is clouds and fog, and there is water vapor. Hopefully that helps. Hopefully you're able to forecast your own weather. Hopefully you're not consuming a bunch of utter crap on YouTube. And I'm going to hide from that utter crap on YouTube and from all the scary spookiness of space. Anyway, see you soon. I might peek my head out of the bunker later, but in the meantime, may that solar wind be at your back. What?